All right, so the first problems I want to go over with you on this first page are 3 and 4, in particular because with rational functions, recognizing vertical stretch and vertical compression can just be a little bit tricky. And so we've got this. I'm going to rewrite this as 1/2 multiplied by 1 over x plus 5. So with the vertical stretch and the vertical compression, you can always take that number, you can kind of pull that out and just multiply it by the fraction. It makes it a little bit easier for you to be able to see it. So here, and actually let me fix this fraction. I'm going to think of this fraction as 1 over like x plus 0 or x minus 0. So here for the transformations, we have a vertical compression of 1/2. The graph doesn't shift left or right at all, and it goes up 5. Then as far as the asymptotes, we have vertical and horizontal. The vertical asymptote is 0, x equals 0. As it comes from the number that's underneath the fraction, and then the horizontal asymptote is y equals 5. So to practice that idea again, we're going to do the same thing with this 3. So a 1 on the top is normal. That means there's like no stretch going on the top if you don't have a number on the bottom to kind of pull out. So like if we look back at number 1 and number 2, you can see that there's a reflection because there's a negative for both of those. But since there's a 1 and no number in front of the x on the bottom, both of those don't have a vertical stretch or a vertical compression. Both number 4, we have a 3, even though we don't have a number in front of the x. So I'm going to do the same thing that I did before. I'm going to pull this 3 out in front of the fraction, and then I'm just going to write this just as a multiplication problem. And so this is a vertical stretch of 3. And the graph moved to the left 9 and up 2. And then we can do the vertical asymptote and the horizontal asymptote. So the vertical asymptote is going to be x equals -9. And the horizontal asymptote is going to be y equals 2. And just make sure that you always write the vertical asymptote and the horizontal asymptote as an equation. X equals a number, y equals a number. If you were to just put -9 or just put 2, in a testing situation, you would be marked down for that. Okay, on the next page. For 9 and 10, we're going to graph these. So the first thing I'm going to do is write the equation of the asymptote and sketch them, and then from there I'll graph it on the calculator. So x equals -3 is the vertical asymptote. The horizontal asymptote is y equals 1. So there's 1, 2, -3. You should put it in as a dotted line because it's imaginary. You should not put it in as a solid line. That would imply that it really was there. So I've got my dotted line and my solid line. Now I can go ahead and graph it on the calculator. So I've got alpha y equals, so I can type this in as a fraction. -1 divided by x plus 3 with a plus 1 on the end. I'll go ahead and hit graph. Okay, and you can see like those dotted lines were not graphed. And if I look here, so I'm not going to see the point -3, 1, but I can kind of look where that point would have been. So -3, 1, you know, that's an error message because it's an asymptote. Now, if you're uncomfortable with this giving you fractions as outputs because those are harder to graph, you can go back to your y equals button, and you can go to the end of your equation and hit the math button right here. And if you go down to number 2 and hit decimal, then it will take everything that you graph and it will turn all your outputs into decimals. So again, to do that, I hit the math button. Let me just delete this and type it again. I hit the math button and I went down to decimal. And so I'm telling my calculator to turn all of these outputs into decimals. So now if I look at the table, I don't see fractions anymore, I see decimals. Okay, so there's the middle of the graph, and then I'm just going to do 2 points above that and 2 points below that. So -4, 2, -5, 1.5. So -4, 2, -5, 1.5. And then -2, 0, -2, 0, and -1.5. And then from there, we just kind of treat the rest of the graph, you know, like it's approaching an asymptote. So since we know how asymptotes act, so we know that curves just get close to them. So I'm going to make the graph get, you know, kind of close to the asymptote on either side. Okay, so there's that one. Number 10, same idea. So I'm going to look for my vertical asymptote. It's +4. My horizontal asymptote is -2. So +4. And -2. Okay, and then I'll go ahead and graph this. So alpha y equals, to plug in the fraction, 1 over x minus 4 squared with a -2 on the end. And I'll hit second graph to get my points. So I'm looking for +4, -2. +4, -2, there's my error. So that's where my asymptotes came together. And then, again, my fractions are kind of hard to graph, or they're hard to tell what they are. So I'm going to hit y equals. I'm going to go to the end of my equation, hit the math button, turn all my outputs into decimals. Hit second graph again. Now I've got decimals. Okay, so +3, -1. +2, -1.75, +5, -1, +6, -1.75. And then I'll go ahead and graph this. Okay. So that's all you have to do for problems like that. The next set, find the domain and the range as well as the end behavior for each of these. So for graphs like these, I just like to draw a little sketch. You don't have to have the accurate graph for this. So I have a vertical asymptote at -1, horizontal asymptote at +4. This is a squared graph, which means that either both of the curves are above the asymptotes or both of the curves are below the asymptotes on the same side. Because it's a negative, they're going to both be below. And of course, you don't have to have that memorized. If you want to use a calculator, that's fine. Okay, so there's my two graphs. It wants me to find the domain and the range. So with the domain from left to right, we know that we're only going to skip this value right here where the asymptote is. So we're going to skip -1. So the way that I write the domain when we're skipping -1 is I say -∞ to -1, but don't include -1. and then -1 to positive infinity, making sure not to include -1. I put a U in between to show that I have two answers and I have to have both of them. For the range, we have to pay attention to which of the rational functions we have. Is it one with a squared, or is it one like this without the squared? The squared has the whole graph on half. The ones without the squared have like everything. They don't just have half of all the values, they have like all the values. So this is only half of it, which means my range is going to be from -infinity up to the asymptote, and then the range just completely stops. There's no more y values after that. So I'm going to have -infinity up to the asymptote at 4. All right, for end behavior, I'm going to say as I look at my left arrow and as I look at my right arrow, and I want to see what both of those are doing, where they're pointing. And if you remember from the notes, I said that this unit is kind of unique in that this is the first unit we've had where the arrows aren't pointing up or down ever. They're completely pointing to the horizontal asymptote. And so you never really have to graph these. You never have to look at a picture. You can just look at the equation. The left arrow is pointing at the asymptote at 4. The right arrow is pointing to the asymptote at 4. They don't go up. They don't go down. They stay at the horizontal asymptote. Okay. So if I'm going to do the same types of questions, but for the other type of graph, the rational function that does not have a squared, I'm going to do the same thing to start with. I'm going to sketch it out. So this one has a vertical asymptote at -6, horizontal asymptote at -3. And then for this graph, the curves are in opposite corners. So if the graph is positive, they're in these opposite corners. If the graph is negative, they're in these opposite corners. This graph happens to be positive, so I'm going to draw them here. So with the domain, we're going to have all of the numbers from left to right except for the vertical asymptote number, which was -6. So I'm going to say from -infinity to -6, but skip -6. And then from -6 to infinity. But again, we're skipping -6. And then because we have two answers, I'm going to put a little u in between. For the range, from up and down, we have all of the numbers. So not like last time, not just half, but we have all of them. But we are skipping the asymptote right here in the middle at -3. So all the numbers, but skip -3. So -infinity to -3, -3 to infinity, with a little u in between because we got two answers. And then for our end behavior, I'm going to look at my left arrow and look at my right arrow. And the end behavior is always going to the horizontal asymptote for these problems. So we don't really have to think about it. As we look at the left arrow, it's going to the horizontal asymptote at -3. The right arrow is going to the horizontal asymptote at -3. All right, next I wanted to look at number 17. So increasing and decreasing intervals for the following. Again, like the previous problems, I'm going to draw a sketch. You don't have to draw sketches of these. If you want to graph them on your calculator, that's fine. The vertical asymptote is -2. The horizontal asymptote is -7. This is an x-squared graph, and so either both of the curves are above the horizontal asymptote or they're both below the horizontal asymptote. That's how these graphs work. Since we have a negative, that means they're both below. So the curves would look like this. All right, so find the increasing and decreasing intervals. Remember that these are both x values. Increasing and decreasing intervals are both x values. So I'm going to start my stick figure walking right here. He's starting at a left arrow, so that's a negative infinity. So he starts walking, and as he's walking, he is decreasing because he is walking downhill. And he decreases right down, this straight down. It's a down arrow, but notice I said down arrow, not right arrow. This is a down arrow. But the x value right here is actually a -2. So he kind of decreases into the abyss, and I don't know, he disappears. And then a new stick figure comes crawling out of this abyss, and he comes up out of the abyss. He increases and walks out of the abyss over towards this right arrow, which is a positive infinity. So we had two different stick figures, two different answers. The decreasing answer is from negative infinity to -2. Negative infinity to -2. -2 gets a parenthesis because it was a vertical asymptote. We're not actually going to touch it. And then the increasing interval is from -2 to infinity. -2 to infinity. So when you do these graphs, the ones that have the bottom being squared, for the increasing and decreasing intervals, you're always going to have one of each answer. All right, for 19, there is no number on the end, so I'm going to go ahead and put a +0. So I'm going to sketch this one. We have a vertical asymptote at 5, vertical asymptote at 5, and then a horizontal asymptote at 0. And for these graphs, the curves go on opposite corners. So it'd be these two corners if the graph is positive, these two corners if the graph is negative. So since the graph is positive, it's going to be these two corners. So remember, again, increasing and decreasing intervals are the x values. And so I'm going to start the furthest left on the graph right here. That's an arrow pointing to the left, so that's a negative infinity. And this stick figure is walking down, kind of over a cliff, walking down. This is decreasing. And this arrow is pointing down, but it's not really pointing to the right. It's knocking into that vertical asymptote, and that vertical asymptote is at 5. So this stick figure like falls into this vertical asymptote, like abyss sort of thing, and I don't know, it disappears. Then we have a new stick figure that kind of drops down right here, and this arrow is not really pointing to the left because it's blocked by that vertical asymptote, and remember that vertical asymptote's at 5. So this stick figure is kind of like walking down into a valley sort of shape. This was like over a cliff. This is like down into a valley. You can see that they're both down. They're just different types of down. So he's walking down, so he's decreasing, and he's decreasing to a right arrow, and a right arrow is an infinity. So for increasing, I'm going to say none. I never saw him walk up, I only saw him walk down. Down kind of over something, down kind of into something, but down both ways. So for decreasing, I'm going to say negative infinity to 5, and 5 to infinity. And put a little u in between because I have two answers. All right, next problem. I'm going to do problem 22. That asks me to find the intercepts for this problem. So I'm going to have to get my calculator out. That's definitely a calculator problem. So I'm going to do alpha y equals -1 over x minus 2 squared with a +2 on the end. So for my x-intercepts, I know that my x-intercepts are going to be fairly close to the vertical asymptote here. The vertical asymptote's at 2, so I'm going to have one x-intercept that's to the left of 2, one x-intercept that's to the right of 2. So for the x-intercept that's to the left of 2, when I do my left bound and right bound, I can kind of keep that in mind, that that answers to the left of 2. So for that x-intercept over here, I'm going to do second trace, option number 2. And to find a number that's to the left of 2, I could do like between 0 and 2 for my interval to kind of look. So I'm going to type 0 and press enter, and type 2 and press enter, and I'm going to ignore the guess and press enter one more time. So there's my first x-intercept, 1.293. And then my other x-intercept is to the right of 2, and so I'm going to do second trace, option number 2. And then for my left bound and right bound, I could use like 2 to 3 or 2 to 4, something like that for my left bound, right bound. So I'll do 2, enter, 4, enter. I'm going to ignore the guess, press enter one more time. So my other x-intercept is 2.707. Okay. For my y-intercept, I'm going to do second trace, option number 1, and plug in 0. 0, 7/4. If you don't like that your output is a fraction, again, you can hit the y equals button, tell your calculator, go to the end here, hit the math button, and 2. This is telling your calculator to turn your answers into decimals. So if we were to go back to the problem and we were to hit second trace, option number 1, plug in 0, this time it'll give us the output as a decimal instead of a fraction. Okay, this problem wants us to do end behavior, so I'm not even going to look at the graph. I'm just going to say, as I look at my left arrow, as I look at my right arrow, I know that both of these are going to go to the horizontal asymptote, which is 2. Don't even have to look. I already know what the answer is. All right. For the last section, we have problems where they're asking us to evaluate two different functions, f and g, by plugging numbers in. So if we're plugging 5 in for f of x, then I'm going to do -1 divided by 5 minus 4 with a plus 3 on the end. And you just have to type it in. So get out of that screen. Alpha y equals -1 on the top, 5 minus 4 on the bottom, with a plus 3 on the end. That gives me 2. All right, for the next one, they said take g and plug in -6. So 1 over -6 plus 5 squared with a minus 2 on the end. So 1 over -6 plus 5 squared with a minus 2 on the end is -1.